Okay, so welcome to inequalities. That is section 7. This will be my last section without Annotator Connor, so we're good. So inequality rules, this goes back all the way back to section 1. So the rules are x is less than y, or x is equal to y, or x is greater than y always. No matter what, one of those will be true. That rule applies for all of these, and that they will never be untrue. If x is less than y and y is less than z, then x is less than z. If x is less than y, then x plus z is less than y plus z. If x is less than y and z is greater than 0, then zx is less than zy. If x is less than y and z is less than 0, then zx is greater than zy. So now we're going to be talking about zeros, roots, x-intercepts. They all mean the same thing, and this is of a quadratic graph. So you can either have 0, 1, or 2 zeros on quadratic graphs. The first way to have 0 is a quadratic graph that has no zeros or x-intercepts. It does not touch the x once, not at all. The next way you can have it is like so, when it touches the graph only at the tip of its parabola. Then the last way you can have it is like this, when it touches the graph twice. Any of these would be zeros, which would also be the x-intercepts, which would be the answer usually to the problem. The last thing we're going to talk about is graphing absolute value graphs. So no matter what your positive x and y input is, that will be mirrored with a negative x input and the same positive y input. So if your graph looks like this, that will always be the same over here. If your graph looks like this, that will always be the same over here. If your graph even goes negative, that will be the same on the other side. That was section 7. Thanks.